So what I've done here on these 2 pages is I've summarized everything you need to know about position time graphs, velocity time graphs. Now normally, do you see how there's a line drawn down the middle there? Okay, and then actually if you flip it open so it's like cold, or like, so like flip it open so you have both pages visible. Okay? And what you'll see is down the left-hand side, hey Junior, what you'll see down the left-hand side says position time graph, and does it say the same thing on the next page too? Because at one time it did, but I had to make people okay. So I'm going to be going down the left-hand column. Okay? I'm not going to be doing a lot of talking today. Okay? So I only really need your attention for about maybe 5 or 6 minutes. Okay? So down the left-hand side, if you have a position time graph and you need to find displacement, how do you do it? You read the positions off the graph and you subtract. And here's the picture that sort of makes sense, right? If you've got a position time graph, right? You simply read those positions and that is your delta D. That is your displacement. Sometimes in the occasional one it's called delta X. I got to fix that. Okay, that's how you find displacement, right? If you have a position time graph and you're asked to find average velocity, well, there's 2 possibilities. It could be a straight line graph. By the way, you should be drawing these little graphs. If it's a straight line graph, you simply find the slope. What if it's a curved line graph? Average velocity, the slope of the line drawn between the points of interest. In other words, you do this. Because it's average velocity. It's not instantaneous, it's average.
What's the top one mean? Like, what's your graph? What are the lines?
You're reading the data points. You're just reading them off the graph.
Oh,
Right? You're just reading those data points and subtracting them. Like if this is 5 and this is 12, then your delta D is 7.
in that area.
No, position time graph, not velocity time graph. From before, position time. No, Ty. You just read the data points and subtract, not the slope. It's a position time graph.
So
It's
that,
a
that wouldn't be that whole line though, right?
no. That would be the displacement between those 2 points. That's right. Yeah. Okay. What if you're on a position time graph and you're talking about instantaneous velocity and it's a straight line graph? It's the instantaneous velocity is a slope. Instantaneous is at a single point, so you, as Dawson said, you find the slope. Any 2 points. Any 2 points. Because it says it's a straight line graph.
No, why is 3 points?
Why is it a 3?
3 points. Yeah, you say no.
You have 3 dots on the graph.
Oh, why? Oh, well, this is the instantaneous one. You pick any 2. Gotcha. What if it's a curved line graph? Tangent line. Exactly. Tangent line. Do you see how important these 2 pages are?
Yes. It's pretty much.
It's pretty much, yeah. It's the manual for the test.
Whoa.
That's just
Now, go to the next page. Junior, I'm only going to speak for like 5 minutes.
Why? They both can't be calculated. What is the matter?
Position time graph, if you're asked to find average acceleration, you can't do it.
Answer right. Go back. Hey.
Was he talking about the wrong thing?
You made a mistake on board number 1.
You just got going.
Okay, so if you have a velocity time graph, which are the kinds of graphs I showed you the last 2 days,
Yep.
right? Velocity time graphs. And you are asked to find the displacement. How do you do displacement? You find the area. You find the area.
Yeah.
Using the triangle and rectangle method, right? Brandon, I'm not going to be doing this much today. I understand what you're doing. Stop it. That's why I'm talking to you now, because I don't want you talking to Jeff.
Well, might as well start talking to everybody else too.
Yeah, and I have been.
Did you just send this?
Well, no, you're wrong. I've told several people to stop talking and listen today. Excellent. Average velocity. If you are looking at a velocity time graph and you need to find the average velocity, how do you do it? You use this formula, v bar equals d over t, where d is calculated as shown in number 1, which means the area divided by the time. Area divided by the time. That's what we did yesterday. Remember, we took all the different areas, we added them together, and we divided by the time.
You said yesterday was the first year?
So far, yeah.
No, he wasn't supposed to say that, remember?
Only hard if you weren't paying attention.
That anxiety video, Mr. Bennett.
There should be a number 3 there. There isn't. If you have a velocity time graph, Zane, if you have a velocity time graph and you're asked to find instantaneous velocity, what do? You read it off the graph. It's a graph of velocity. You just read it. Yes, the lesser known B-side of the Michael Jackson song. You just read it.
And finally, never mind, there's 2 more.
If you have velocity time graph and you're asked to find average acceleration, and it's a straight line graph, you just take the slope.
Why do you cancel those 2? Oh.
If you have a velocity time graph and you're asked to find average acceleration and it's a curved line, average acceleration, draw a line between those 2 points and find the slope. That's why I'm doing it up here.
So is the line straight or is it curved?
Kurt.
Curved.
Draw it. So, simple as that.
If you have a velocity time graph and you're asked to find instantaneous acceleration and it's a straight line, you find the slope. If you have a velocity time graph and you're asked to find instantaneous acceleration and it's a curved line,
Exact same thing as 8, like 4,
right here?
Yeah, say.
Yeah, because if it's a straight line graph, the instantaneous acceleration is the same as the average acceleration because it's a straight line. Whereas down here, it's going to be a tangent because it's instantaneous slope, not average.
Okay, so what do you do there?
Draw a tangent line, find the slope. Given all that, if you've been sort of following along and paying attention and maybe doing some practicing, you'll have no trouble completing this pretest assignment, which I just realized I forgot to put on colored paper.
Oh, it's handed.
Probably just don't have to hand it in.
No, just put the words handed on the top.
I'll just come around and put highlighter on everyone's, right?
Squiggle everywhere.
There is no reason why you can't be done this by the end of this period if you've been doing what you need to do.
Wait, is this second?
Okay? This is a velocity time graph with everything on it. There-